We are on finishing up 13.2 today. This is page, I don't know. Yeah, 975. So here we go. This is the thing that we were trying to understand yesterday. Now we're going to get into a little bit more. What are radians? Radians are another way of measuring an angle. Look right here. Radians are angle measures, not linear measures. So linear means like if you're measuring the length of something. Radians are not to measure the length of like a rope. It is to measure the angle that the rope is maybe placed at. Does everybody understand the difference? So if I said something is 90 degrees, I can take that 90 degrees, and today we're going to learn how to change it into radians instead of degrees. So here's what radians are. Radians are the ratio of the intercepted arc to the radius. That is definitely going to be something you need. That is called radians. So let's look at Sandy and Josh. They want us to determine the radian measure for this central angle. Does that make sense? Well, I go back up here. What are radians? The intercepted arc length. So what's the first thing I need? I need the arc length. With me? Well, do you remember yesterday the first thing we did was arc length formula? And it was the arc length equals the circumference times the central angle divided by 360. That's what we did yesterday, the first thing we did. That finds the length of this arc. Does everybody understand that? Well, when I do this, 45 divided by 360 turns into 1/8, just reduced. 2 times 2 is 4 pi. The 4 and the 8 cancel. This is over 1. So 4 turns into 1. 8 turns into 2. Pi times 1 is just pi. And over 2. Does everybody understand that simplifying that we did? Now, no, this is actually finding this length. Those are radians. Those are actually the measure of those angles. Just wait. You'll get it. Does everybody understand what we just found? We found the length of this arc based on this radius. Yes? Now, what do I have to do? What does it say for radians? I've got the arc length, but it says it's the ratio of the arc length to the radius. So where does Josh go wrong? Josh just says, hey, pi over 2, that's also the radian measure. No. Josh forgot to set it up as a ratio of the arc length to the radius, which is what Sandy does. A ratio is really just a division. The arc length divided by the radius. Do we divide by fractions or with fractions? Keep, change, flip. This becomes pi over 2 times 1 over 2. 2 times 2 is 4. 1 times pi is pi. Pi over 4 radians is the real measure of this angle in radians. Now, why does that make sense? Look at your 45-degree angle on the. Go look at your unit circle. What is 45 equal to on your pi over 4? Does that make sense? Do 36. Do the same problem but 36. And radius is 5. Should take you just a minute. Here goes Chris in his head. The radius is 5. I really wish you'd start writing stuff down. Alright, so here we go. You should have put 5 right here. You should have put 36 right here. 36 over 360 really reduces to 1/10. 5 times 2 is, so we have 10 pi. Instead of here, we have 10 pi times 1 over 10. What happens with the tens? Cancel out. So what is my length of my arc for that one? Pi. Pi units. Just pi. Is that that's my arc length though, correct? How do I find the radian measure? It would be pi divided by 5, or pi over 5. Done. Not a big deal. That makes sense. Yes, sir. The ratio, or the radius. That's it. Yep. Now, this is going to help us out. I think this next set, we're not going to do this. We already did that. That's finishing out the unit circle. We did that yesterday. This is where we're going to get, so you should have this filled in. Again, I'll put this up on YouTube. We talked about this yesterday, how this is 30 degrees, 60, and we talked about how this is really a 6. This is really 2/6, which reduces to pi over 3. If you need help on the unit circle, make sure you come see me maybe after school or something, set up a time. It's not a big deal. We filled this in yesterday. These numbers are not made up. They are just the fractions reduced, and it makes sense. Yes, sir? That's going to be, I thought we were going to get to it today. We're not going to. There will be another one filled completely out. But I want to make sure we understand radians, what they are. Okay. Hopefully this will drive it home. Do you understand that when I say pi over 4, it really means 3.14 divided by 4? And so that really means that it's 0.785. Yes? Same thing with this. It means that I take 7 times it by pi, then divide it by 6. So what if they ask me to estimate? They want me to estimate the degree measure of the central angle if I'm given 3 radians. Give me a minute. Right up here, you see that this says pi over 6 radians. What is that really close to? It's really close to a half. Let's just make pi what number? Really, just because we're estimating only. What can we make pi really? Pi. 3. What's 3 divided by 6? So wouldn't this be close to a half radian? Okay. What are we looking for? 3 radians. Okay. Let's keep moving along. We're at a half. That's not really close. Let's go to this one. What do we say that this is really? What's 3 divided by 2 close to? 1.5. Are we at 3 yet? But think about this. If this is 1.5, what is this going to be really close to? What is this measure in radians really? This measure in radians is really 3.14 radians. And that's 180 degrees, right? What did they ask me to find? What is 3 radians? And they asked me to estimate it. So what am I going to say that it's really close to? It's close to 180 degrees. Does that make sense? What's the next one on that chart? Let's go to this. Okay? Actually, this one's not written here. What are we estimating pi to really be? 3 times 2 is what? 6. Yes? So this is really 6.28 or something. Somewhere in there, right? That's what it's going to be close to. So if they ask me for 6 radians, isn't 6 radians going to be really close to 2 pi? So what is 2 pi really equal to? Not just this. It's really also, it's both. Remember, we're talking about a Ferris wheel. Think about it. It makes sense in terms of it. As far as sometimes you can travel around this. You can travel around this and end up in the same location. You just rotated 2 times instead of rotating. Just keep it. How many times did I rotate if I just go 0 degrees? I haven't just rotated any, right? But if I rotate 1 time fully and I end back here, I've gone 360 degrees, but I end at the same location. Does that kind of make sense? That's why, again, the Ferris wheel kind of makes us understand. Now, for 6 radians, though, I'm going to have to travel around the circle. You do want to show that. So it's going to be closer to the 360. We're not going to say it's close to 0 degrees. We're going to say it's a little less than 360. So probably somewhere around 355. But all they're asking us for an estimate. So I would say it's a little less than 360 degrees. Because 6 is a little less than 6.28. Following me? Next one. Is this driving home the idea of what radians really are? 2. All right? Let's go up here. Do you remember this one? What did we say this was close to? So if I know this is about 1.5 radians, and I know this is 3, I know 2's got to fall somewhere in between here. Correct? Okay. So what did we say we use for an approximation of pi? Just real quick, right? What's 2 times 3? 6 divided by 3 is? So this is a little bigger than 2 radians, so it's going to be a little less than 120 degrees. Are you guys following me on how to do this?
So for looking at 2 radians will always be the same length on the unit, right? The same,
2 radians is always going to be the same. Just like, think about this. Remember, radians. Yeah, but remember, listen. Radians does not determine on how big the circle is. This circle right here and this circle right here, 2 radians is the same measure. Just like, it doesn't matter which circle is what I'm trying to tell you. Because look, this is 90 degrees, correct? What is this? But it's on a smaller triangle. What are they measuring? They're measuring the angle that this is. What does radians measure? Angle. So it doesn't necessarily matter about the size of the circle. So it doesn't matter if it's on the unit circle.
So like
2 radians is going to be 2 radians because it's really the measure of the angle, not the distance. Now, this arc length is going to be way different than this arc length, right? This one's going to be bigger. But that's why it said in that bubble, big time, make sure you understand, it's not the length. It's the angle, degree. So when you think of radians, think of degree. That will help you out. All right? How are we doing? Good? What's the next one? 4. So if I was going to go on 4, I know it's bigger than this. 7 times 3 is 21 divided by 6. Well, I'm looking for 4, right, Chris? And 6 times 4 is 24, not 21. So let's go try again. 5 times 3 is 15. And 15 divided by 4, get kind of close, because 4 times 4 is, so watch this one. 4 times 3 is, and 12 divided by 3 is 4. So isn't this one really close to 4? So I know it's going to be a little less than 240. We making sense on this estimation part? Now, there is a way to turn radians, and this is, I wish we do a better job of conversions. Hopefully this will help you out. We are going to actually be able to convert radians to degrees and degrees to radians because they measure the same thing. They both measure the angle. Does that make sense? So let's go back to middle school when I wish we did a better job of teaching conversions. Because I can remember back when I did it, no one explained this to me. And again, I find out things later on, I'm like, why didn't you just say this? I would have been so much better on all my conversions and not hated them. I hated conversions. Now I understand them. They're not that bad at all. So let's do something pretty easy. Let's do 12 feet, and I want to convert it to inches. Am I allowed to change the value of the 12 feet? It's still going to be the same length. I'm just going to measure it differently. I'm going to measure it in inches, but it's the same length. Does everybody get that? So, I'm not allowed to change the value of this. What is the only number in the world that doesn't change the value of the number, but it can change the way it looks? What have I been preaching all year long? 1, correct? So I have to times this number by 1 over here. But I can make the fraction 1 look really funky. Does that make sense? Now, do you see feet right here? They cancel out. Just like, you remember how feet times feet turns to what? Feet squared? Guess what feet divided by feet does? Cancels out. So you see how I have feet up in the top? How am I going to be able to cancel the feet out? Is if my feet for this one is located in the bottom. Does that make sense? 1. Right. But now hopefully you're going to understand why this works. Is because the feet literally cancel out with the feet. How do I make this look like, it's going to be a funky looking 1, but how can I really represent it as 1? Is if I say 12 inches up here. Because 12 inches is the same thing as 1 foot. So really, what is this number right here? It's the number 1, but it allows my feeties to cancel out and change it to inches. Now, here's where this really helps. Do you remember those fun conversions where it says they want you to take 50 miles per hour and change it to feet per second? Do you remember that? Well, here's what you want to happen. What is the only way that I'm going to be able to cancel out hours? If my minutes are in the top, my hours are in the top, my minute has to be in the bottom. Huh? But, so if I want to do this down to seconds, then what would I have to do? Then I'd have to do this right here. Here's what I would do. I would do hours down to minutes, and then 1 minute. And then again, what happens here are my hours cancel out with my hours, my minutes cancel out with my minutes, and I'm able to convert it like that. Does that make sense? And you just multiply top times top. Same thing with the other, changing the miles to feet. Just cancel the stuff out. Does that make sense? So, watch what's going to happen here. If you understand that concept, and when we change radians to degrees, the only thing you need to know is this one thing from your unit circle, which you should know. What does pi radians really equal? What does pi radians? 180. Remember, you need a unit because we're changing the units, right? We're going to be changing them back. So I need pi radians equals 180 degrees. If I know that fact, then I can do exactly what I just told you. If I say I want you to change 3 radians into degrees, you would put 3 radians over what? Times it by? What do I want? Where do I want my radians? It would be 180 degrees on the top, pi radians in the bottom. Because what is this really right here? What is that number really?
1.
1, because they're equal to each other. Whenever you have the same thing over itself, it's really just a funky looking 1. So really I'm just tying these radians by 1, but it allows me to cancel my radians out and change that from radians to degrees. Because degrees is the only measure left. Does that help with conversions? Has anyone ever showed you that kind of stuff?
Oh, yeah.
Oh, yeah.
Okay, good.
Yep.
I wasn't.
I learned that.
Yeah, but were did they like the radian, how these cancel out, one being the top, being the bottom?
We do like 20 of those bars. And
Yes.
you go from like.
But I hated them.
It's
They did teach in 7th grade. I stopped the book. I didn't.
They showed us, but they didn't talk to us through it.
I didn't.
Yeah.
That's why. I don't like it.
Right, I had no idea what was going. Alright, until you use it a lot of times and you can kind of, just flip it, but it makes sense that they would cancel out its fractions. How are we doing? Good on that so far? Right here. There you go. They just teach it a different way. Look, what did I teach you? Instead of having to memorize the formulas, you just understand the concept. Does that make sense?
Yes.
Alright, this one is pretty cool. This one goes back to geometry. Who can remember what complement means? And no, not on my hair. What does it mean? Means, so, think about this. If I say, well, you don't have to throw stuff. If I say, this is 55 degrees, and I ask you for the complement angle, what did you do? You took 90, and you minus 55, and you found out that the complement was what?
Yes.
Right? Does that make sense? But what if I told you this? What if I said, hey, I've got an angle, and it's pi over 3. What angle complements that? Now what measure am I in? What? No, you don't change degrees. What am I in right here? I'm in radians. What does this really equal? 90 degrees is really what? From your unit circle. It's really pi over 2 radians, correct? Same thing that I did before, except instead of 90 minus 50, which you're used to those numbers and you like, you're just going to be doing pi over 2 minus pi over 3. We understand we can't just subtract fractions without common denominators, so I times by 3, times by 3, times by 2, times by 2, and I really get 3 pi over 6 minus 2 pi over 6, and I realize my complement to pi over 3 is pi over 6, because pi over 6 plus pi over 3 will equal pi over 2, aka 90 degrees. Thumbs up? Remember I told you can't be afraid of fractions, they just start coming up more and more and more. Look at your unit circle. What are all of those measures? Fractions. There's no, we don't want we don't want you to estimate, unless the problem says, estimate this. Other than that, you're going to leave in terms of pi, you're going to leave fraction work. You've got to make sure that you can understand it. Do not turn them into decimals. Good? Go ahead and tonight I want you to, I'm going to put the skills practice up. I want you to practice the problems. And I haven't decided yet. If there's a video, I'm going to post this one. And I might be posting 13.3. I've got to look at it, see if I wanted to do this in class because I wanted to see and make sure. It's a good thing I can't see you at home. But I can see your faces here and see, yes, you're kind of getting it, or no, I need to go over it more. So I really wanted to get the first couple lessons so we had a kind of understanding and then maybe go back to the videos. Good?